Hello, and welcome to my presentation on event-driven flows with AsyncAPI and Go. I'm Marius, I'm a solution architect at Signicat, and I hope that I'm presenting you some interesting topics. Before diving into the details, let's just start with the agenda. We'll just briefly present just a high-level overview on the event-driven architectures, at least for those of us that are not yet familiarized enough on the topic, of course, with all those benefits and challenges. And then we'll dive into a, let's say, more specific aspect that brings quite nicely the technical part with some business-related benefits. And then we'll get even deeper into the technical parts, looking at the async API and what this provides to us. And of course, we'll have a demo to show off some of the principles that we'll present here. A little bit more myself. I'm a solution architect. I still love the conceptual model because to me it's the core of what we'll do, whether it's business or development. It's like the ubiquitous language on domain-driven design. I love to work on banking and finance domain because these are complex enough to bring you a lot of challenges and bring a lot of interesting things or systems to create. I also got in love with the events and event-driven architecture while doing some implementation and even software development while being a software consultant at IBM. And I'm also still loving doing software development because to me, that's the part that brings a lot of creativity into the table. Generally, I'm more prefer Go than other languages, but that's just a subjective matter. Event-driven architectures. Just briefly, we don't necessarily have to get into too much details at this point because this summit also, I guess, will cover a lot about this. Well, what's important, again, just a warm-up into the topic, would be the following, that we know that event-driven architecture are not just something that has recently been discovered or invented. It existed for quite a lot of time. But I would say that the internet and those transport protocols like TCP or HTTP that mainly involved synchronous interactions just drove and influenced quite a lot the design of systems. So that's why we'll still see many of the synchronous interactions, whereas event-driven architectures involves more asynchronous interactions and more loosely coupled ones. And we'll see, of course, some of those challenges and benefits that comes with that. What's also important, still as a very brief overview on the EDAs, is the fact that nowadays, through those events or messages, we'll also briefly get into the difference between those. We actually, that would actually allow us to react more rapidly, more sooner than later. We don't have to wait for some nightly batches to be processed like it was in the past. So we are able to have access to something like near real-time data, depending on the needs. And of course, we allow our systems to react more naturally, depending on their scalabilities and throughputs. What's also important that event-driven architectures are actually providing, in terms of scalability, higher levels of throughput compared with the synchronous ones. And in many cases, we'll see that event-driven architecture and higher scalability implies some eventually consistent setups. And then normally an eventually consistent means something that would eventually be completed whether successful or not. And that's the whole asynchronous part. And EDAs mainly involve three main type of participants. We have the producers, we have the consumers, and we have something in the middle that you'll already see it as a message or event broker. What that does is basically just a router in most of the cases, capable of receiving a lot of events, capable of keeping up with the throughput from the producers, because that's quite a key component in the infrastructure, but also able to route those events to even multiple subscribers, as we'll see here. And at the same time, it doesn't mean that each and every event gets duplicated, but from the consumer perspective, each and every consumer will get its own copy, let's call it like that, of the event based on its subscription. And speaking about the messages versus events, just wanted to point out that normally a message, it's a piece of data that is being sent from one system to the other. So it's a dedicated element that is being sent in a point-to-point interaction. So one system could talk directly to another through a message. That's basically the example what we have currently with HTTP-based interactions. When you have a client and you have the server, so you send an HTTP request, and that would be like a message. And that's the first one of those three most popular interaction patterns. The second is publish and subscribe, and that's actually more related to events. So whereas a message is just something that is being directed to one system as a destination, an event is something that it's like a fact and is just being published somewhere, and multiple parties can subscribe to that kind of event, and each and every party will get its own copy of the event, right? And of course, there is a newer, let's say, popular interaction pattern that is streaming, which brings also a lot of value for different use cases. And in this case, consider streaming like a flow of data that is continuous by its nature. So in this particular case, we don't have necessarily actors like producer and consumers or publisher and subscriber, but in a general way, it's pretty much the same thing. Of course, different platforms regarding streaming are more specialized, like Kafka. It's being a distributed log streaming would also allow you as a consumer to just go back to some past events, not necessarily you consume it and you just have to live with that. And of course, like we mentioned, the important part in the middle, the message broker or event broker, that's a specialized piece of software to not necessarily just support those interactions patterns, but also be able to support high throughput, be highly scalable, and of course be resilient, because that's like a backbone of an EDA to some extent. Let's speak a little bit about the opportunities before we get into the challenging ones. So the opportunities, like we mentioned, events being a fact about something that happened in the past, then implies that one or multiple participants in our ecosystem could just react to that, right? Funny thing is, like, semantically speaking, system could get reactive, but actually in a proactive manner. And we'll see a complete example about that. Also, naturally, there are multiple real-world workflows that could be done just based on events, because by their nature, it needs some time. Sorry for that. It involves multiple participants, and even more important, if, for example, a workflow covers even multiple countries and so on, not all the participants are always active at the same time to all contribute to the flow and have the flow complete in a, let's say, near real time, near instant manner. So that's the case for those saga, what they are called patterns, which means just a flow that could take a longer time, not like a minute or hour, could just take days. And of course, normally asynchronous interactions won't allow to have such a long time established connection. Also, importantly, is the fact that if we have events, then we could easily capture those, and that means more easily compared with the HTTP APIs, for which you need to have some, or you could have some specialized infrastructure element that is capable of understanding the HTTP protocol and capturing all the requests and responses, and eventually have them correlated and so on and so forth. So, and these are actually the cases where patterns such as event sourcing or CQRS are promoted, meaning that through event sourcing, you are able to capture each and every change state of an entity. So then in the end, you could have the current state of an entity by just applying all the past changes to it. and CQRS is just command query and responsibility segregation, meaning that you could have two different systems, specialized one for doing the command, that means processing the changes, and the query part would be just another system that would be more specialized for just providing the data for just consumption, not changes. And Elastic, it's in a more seamless way, meaning that it's like in the reactive manifesto, the system could just scale up and down depending on the throughput. And because this one involves this decoupling between the producer and consumers, and always have this broker in between, then it means that the consumer, it has a lot of freedom to scale its instances as much as needed. And it's absolutely something that is encapsulated, and the producer is totally agnostic about what's happening. Now, by its nature, a distributed system, like an event-driven architecture implies that we have a distributed business logic. And now that's the challenging part, because yes, we also have microservices that has it's a distributed system with specialized components, specialized services like bounded context in domain-driven designs. So why not keep using the microservices? Well, actually, the microservices are more promoting the HTTP API, although in a wider from a wider point of view, we could still consider microservices in an event-driven architecture world, right? But what's important here, actually, the difference between a classic microservice with HTTP-based APIs, with EDAs, and that is with event-driven logic, then actually we have events flying around. So we don't have point-to-point interactions between a HTTP client and an HTTP server, but actually we have a service that is just publishing an event, and potentially one or multiple services that will just consume the event, react to that, and so on and so forth. And now suddenly you feel like you don't have a control, you don't have a proper governance about how the things are flowing around, right? So that could be a potentially scary. Of course, we would also have a different security model. We don't have JWT tokens, JSON web tokens, as are currently being quite popular on the REST API, but that's not actually the main concern. The main concern is how do we able to govern what's happening regarding those events, so we don't lose control, and at the same time we do something that is consistent and easily understood, so that new people will have a quicker and nicer onboarding into the topic. Last but not least, let's not consider that event-driven architecture becomes a problem for the normal cases that we pretty much are aware of, and that is the fact that we might have interactions between system, even external partners, and normally these are done based on HTTP APIs, because we don't want to expose the event broker in many cases to the external world. That's quite a risky scenario. But of course, in this case, we also have at least one option, and that is the asynchronous request and reply pattern, when, of course, the client could call through HTTP, right, the server, and the server is just responding to 202 that is accepted, and then, of course, could get back a link to where to keep polling for a status from time to time. And eventually, when this is done, when the things behind the scenes are completed, then, of course, you'll get a 200, and that is okay. So that's the final state. And of course, we also have the other use case with webhooks, which in this case, the client don't have to keep polling us from time to time, but actually we could call them back as long as they provide us on a webhook endpoint, where we will be able to deliver them when it's happening, the end result, whether it's positive or not. Now let's get more into the business part of things, because high level speaking, that's okay. We'll get into the technical part, but I would like to try to merge those two together in a nicer way. So we have event-driven architectures. Now let's consider the flows, and regarding these event-driven flows. And we all know about those activity diagrams or flow charts, when we have multiple steps or participants and some interactions between them, whether those are operations or events, doesn't necessarily matter. What is matter is that there are multiple steps and multiple participants in such a flow. Now, through events, we also have this, again, that nice offering that is the flow in itself doesn't have to complete in a short amount of time so that the HTTP connection does not time out and eventually be dropped from the client or the server or any intermediate network hub. But also what's important is that while it's in progress, we could also have a state of the flow instance, right? We have a flow definition, and for each and every start of a flow, then we have a new instance. And then, of course, through those events, having a definition of them, we will be able to show the progress, like what's happening, who should be the next participant in the flow, whether it's human or just a system that should do its own part so the whole flow eventually will complete. And last but not least, business activity monitoring. It's also quite nicer to implement, because now that we have events and we have a definition, then we are very easily in a good position to be able to measure times for each and every flow instance, aggregate those, and eventually render some nice decisions about whether a flow is efficient or not, if it takes too much or not, and so on and so forth. Going more into the business side, and actually in this case more on the user experience side, we also have another interesting part. So besides the orchestration or choreography, as we discussed, on the UX side, we have something quite interesting, and that is the fact that we know that sometimes we might have outages. That is, one or multiple participants in the flow might be down for a while. Now, what we can do, we can either inform the customer like, sorry, this feature is temporarily unavailable, because we know that upfront the flow will crash because some of those participants in the flow are not available. Or we could just tell the user that, okay, this feature is still available, but you need to be aware of the fact that this will be done in the background. Like, we will eventually notify you through the same web UI or some email or SMS, whatever we have as features. So don't expect to have let's say, instant answer as you were used to have, right? So that's what is called service degradation. The system is still up and running, available, but the parts that are actually not available won't even be accessible. And it makes sense to have that because we know there is a problem. So why just giving the user the access to access something, the chance to access something, and of course that should fail. That's not a nice user experience. I would prefer to have something eventually be completed, as long as that's not urgent, of course. Now, I just wanted to present my flower design patterns, if we can call it like that. What's important here, we'll get into this orchestration, choreography, and even hybrid, is the following regarding the events, of course. In all of the cases, we'll do the tracking. So orchestration means that's not necessarily related to events, but we can also leverage events to a greater extent. Through orchestration, we have a central component that basically orchestrates the whole flow. And as you can see here, we have commands event as an event, and we have reply as a confirmation or a report of the end results. And through orchestration, for me, from a central place, I will always have to call each and every system or service, in this case, that it's part of the flow, and all of those are important. And of course, this might imply retries when this service times out or stuff like that, or even eventually cancel the flow. And that's the orchestration. The choreography, that's quite a nicer one, because what's happening here is that through the orchestration mechanism, if the orchestrator instance goes down, I would have to be able to have another instance of that to basically just resume the state of that flow and eventually continue, or otherwise the whole flow or all the flows that we're currently running will fail together with that instance. On the choreography part, whether that's being triggered from a central place, like we have in this case, the one and only command event, or just triggered from an external place, I could still do the tracking. And choreography means that those systems will just naturally interact with one another. So each input of a service generates an output, and an output of a service becomes an input of the other one, and so on and so forth. That's at the edge of this circle. Whereas from tracking perspectives, this central place, and that's basically a subscriber in a pub/sub terminology, will capture all those relevant events. And by the way, that's the same event, is basically the output of each such service, which implies that here the choreography part could also be down for a while, depending on the throughput and so on, but that's not that important and drastically impacting the whole flow execution. And of course, a hybrid mode can also be something interesting in some of the cases. And one of the cases that I think is important is actually this one. So normally, again, this triggering event could be sent from a central place or could be just coming up from an external system through even an API layer. But what's important here is that because this one has the tracking of the flow instance, so it has all the context, the full context of the flow through what all these events are being captured, this central orchestrator in this case could just send this event to one of those participants, and that events could be complete enough. And that means that as in all the other cases, the events could just react based on the services could just react based on events, and they don't have to necessarily call out other system to get additional data that's not part of the event. Depending on the cases, we don't always expect that the event will have all the data that we need to just react to that. But that's a chance to have it done. So the design won't restrict us in any way. Again, considering that we have a flow definition, then it means that we could use it for orchestration. We could also use it for choreography and even for the hybrid mode. Now, let's briefly get into some high-level example. Let's imagine that normally a flow, it contains one or multiple steps. Some of the steps could also have some sub-steps if necessary and relevant for that step. Steps could be sequential, and in some cases, steps could be done in parallel, such as step 3 and 4. Now, imagine that if we have this one, of course, visually could be shown as a Git flow, or as we currently see as implementation of distributed systems with those traces and spans. If we have this definition and we capture all the events that are happening, then we will be able to capture the state of that flow instance and even react to that depending on the cases. More to that, at each and every step of the flow, we generally know that there is a source and there is a target and there is a data. The data could be just HTTP request and response if we would still have, in some cases, not just a fully event-driven flows. But let's consider that just to simplify things, that we have just events, and that would be an event definition, right? So through this, we would be able, and then getting some information from external places, we would be able to capture the state, and also will be able to react to those capabilities that are being designed based on flows. And we have a definition of the flow, and then depending on the case, like one complete service is down or just one operation of the service is down, we would be able to render some decisions such as, this flow won't work because of this, or the whole service is down or just that operation is down. And we could also inform, like we mentioned before, the UI part of that. Quickly getting into one of the interesting initiative, and actually it's an open source one, that aims to be as simple as what the Open API is for the REST APIs. And I can assure you that it's pretty simple and very, very friendly to use. The community is nicely onboarding everyone that wants to just use or even contribute back. The point is that easiness means that we should be able to define, to have a specification for those events, same as we have the Open API specification for the REST API. And based on that specification, we should be able to generate code, do also discovery, have an event management and catalog, and so on and so forth, right? what's important to have this one able to do is the fact that we have this abstraction between what's a message in terms of structuring and what's a protocol binding, because through protocol binding we get into the technical aspects, what the server is being used, what's the protocol that is AMQP, MQTT, WebSocket, and so on. And then of course this one will allow us to have things nicely designed. As a brief skeleton, we have, and we'll get into an example, we have channels. Consider that those as topics or queues, although in some particular cases, like the rapid queue, could also be an exchange. Now, per channel, we have an operation that could be either publish or subscribe. We have the message that is being either published or subscribed, and we have the binding to that particular technology, and we have the server that it's specifying the endpoint and how that is being accessed. And of course, component could be just reference to those definitions. So consider a definition being in line or just refer to these components as a section. The format could be YAML or JSON. Of course, the YAML it's more succinct than JSON. And as an example, beyond the information, default content type, application JSON, and the servers, as you can see here, we have a name of the channel, account debit disabled, and we have the binding technical part. And then we have the operation, in this case, subscribe. This specification actually is telling to the customer what can do. So in this case, it's basically the opposite of what we expect. That is, in this case, means that through such specification, I would be able to generate a publisher. And if I'm just changing to publish, I would be able to generate a consumer, and we'll get into the details in a minute. Now, of course, the definition of that could be just a reference, not necessarily in line here. And you can see here the same reference can be accessed like that. And a message normally has a payload, business related, and might also have some headers, like, for example, the version of the event, which does not necessarily have a business value. Quickly, let's go into the demo because time flies. What we want to showcase is actually this one that we presented before, such as, let's imagine that you have two services, an account service and a payment service. This, like in an internet banking system, that would be like for domestic payments or intra-bank payments, or transfers, whereas this payment service could be just cross-banking, even cross-country payments, right? Now, what's important here, we have this service that I just called it status quo, which is able to, by just subscribing to all those relevant events that are being sent by these services, be able to react and render some decisions that the UI would be able to react to. Technically speaking, from a software tech perspective, because we mentioned that we'll use AsyncAPI as a spec and code generation, and the Go language, we have to Go services. That one is simulated because it's basically the same story, and we have a UI that is based on Vue.js, and we have RabbitMQ as one of those popular MQP broker. From interaction perspective, things will be like the following. We have the accounts service that could send either account debit disabled or enabled through the payment to the event or message broker. And then, of course, this service will capture all the events that are being sent to it, whether it's from the account or payment, and eventually react to that by sending some server sent events to the UI. I just on purpose chose to use SSE compared with WebSocket because in this case it's just a need for the just getting the notification from the back and not necessarily calling it back. I will just jump into the demo because I think that I don't have enough time. Basically, how to generate the code, that's the spec. If we just look into that, it will look like we saw on the slides, right? See the server, the channels, and so on. And then that could be generated. If we see like the publisher part, we'll use the AsyncAPI generator. We mentioned the spec, then we mentioned the template, and then as an output, just a minute, the directory where all the all the code will be generated. Same as before, if I want to generate the subscriber, in this case, it's a similar case. Actually, that's the standard template being used. That's a temporary one because this publishing part is about to be merged into the master. And same as before, I could be able to generate that subscriber. And as long as this one is eventually being done, I would have a code similar to the following. Interesting enough, the subscriber got generated sooner than the publisher. And the code being just a Golang code, just like that. I won't get too much into the details. Here, I would be able to just, the whole thing, the connection, the whole minimal bootstrap is being done. I would be able to just publish events that are being generated as struct in Golang, also into the code here. See, that's the payload. It's just following what I just put it as into the spec. Then I would be able to just define a message or instantiate a message and published. And similar cases with a subscriber. And now, because I don't have the time for that, I will just show you the end result that would include what I wanted to show. So again, remember that we had that UI part. I would have to start the accounts service. That's the status service. Let me just run dev. Both, as you can see, are just subscribing to the broker, the AsyncAPI broker, and now we have a status, right? So we are able to do the internal payment because the account API is up, or even the account is okay, or we could do external payment because the payment service is up or down. Now, what we can do, just to finish this demo, is as follows. If I'm going to into the account API, demo account API, then I would be able to just send an event such as freeze account 1, and then boom, this one is being sent by the account service, is being captured by the status, and then is being sent to the UI. How is that possible? Because actually that's the ACC connection that is being used. And last but not least, just wanted to show you how things could become like a Christmas tree effect. And that is just like that. So imagine that different things might happen, such as an account would be able to process internal payments or not. You'll see when things are being disabled, the button is being disabled, just for illustration purposes. And that's how the system would react, not just to fulfill the flow event-based, but also react from a UI perspective so that the end user will have a pleasant user experience. And that being said, these are let's say the main reference regarding the AsyncAPI specification. I highly invite you to take a look on that and also join the Slack community. The AsyncAPI generator that is able to generate even HTML code and code specific to TypeScript, Golang, and some others in the future. And what we used in this particular case is it's something that is based on Watermill, which is a nice and friendly Go API library, for having a nicer event-driven applications. Thank you, and hope that the presentation was being excited and gave you some interesting ideas.